Welcome to qnawire.
In this question, we are given a man of mass 60 kg is standing on a weighing machine. As you can see over here, this is a weighing machine over which the man is standing, and this weighing machine is placed inside a box. The man is holding one end of a rope, and the other end of the rope is connected with the box as shown in the figure. The mass of the box is given to us 30 kg. In the first part of this question, we have to find what is the weight as shown by the weighing machine if the man is able to make him at rest by holding the string. In the second part of this question, we have to find that what extra force the man should apply on this rope so that the weighing machine will show the exact weight of the man. Okay, so let's note down the data first. The mass of the man, I will write it as like m of m1, let's say. So the mass of the man m1 is given to us 60 kg. The mass of the box, let's say, that is m2. Mass of the box m2, that is given to us 30 kg. Okay, now as the man is holding the string, so on the string some tension force will be acting in the upper direction, that is T1. So this tension force will be acting on the same box also in the upper direction, that will be T1. The weight of the man will be acting downward, that will be m1g. On the man, a normal reaction force will be acting when as the man is standing over the weighing machine. So a normal reaction force will be acting on the man, that is, let's say, R1. Okay, the weight of the box will be acting downward, that is m2g. On the box, this normal reaction force will be acting downward, that will be again R1. Okay, so these are the forces acting on different systems of this arrangement. Okay, so now if I draw the free body diagram of man, so I will write FBD of man will give me here is the man, let's say mass is m1. So the m1g force is acting downward on the man, the tension force is acting upward on the man, that is T1. In addition to that, the normal reaction force R1 is also acting on the man. So if as the man is able to manage himself at rest by holding the string, so we can apply the Newton's second law, and we can just say that the net upward force, that is T1 plus R1, will be balanced by m1g. So from here I can write that R1 is equal to m1g minus T1. M1 is 60 kg, so it will be 60g minus T1. Let's say this is my equation number 1. Now if similarly I write the free body diagram of the box, FBD of box, as you can see on the box, the upward force is acting due to the string, that is tension force, that is I have denoted as T1, and the downward force which are acting on the box is its weight m2g plus the normal reaction force, which is R1. So for the equilibrium of the box, as it is also at rest, we can write that T1 will be equal to m2g plus R1. Okay, so let's say this is my equation number 2. So from 1 and 2 I can write, from 1 and 2 we can write that R1 equals to 60g minus, in place of T1 I will place m2g plus R1. So this will give us 2R1 is equal to 60g minus m2 is 30, kg, so this will be 30g, which is 30g. So then from here I can write R1 will be 15g. This is the weight of the man, right? This is the weight of the man as shown by the weighing machine. Okay, so as we know that any weighing machine measures the weight by the normal reaction force, so I can just write that this is the weight of the man in first part. Okay, in first part, so I will just write that the mass as measured by the weighing machine is going to be, let's say that is m1, that is going to be the r1 divided by g, which is going to be 15 kg. So this is the answer for the first part. In the first part, so we can just conclude that the mass as measured by the weighing machine is going to be 15 kg. Okay, in second part, to get the correct weight of the man, he should apply some extra force on the string, let say T prime, so that he will accelerate upward with an acceleration a such that the weighing machine will measure his actual weight. Okay, as the actual mass of the man is 60 kg, I will just write as actual mass of the man is 60 kg, so the weight measured in this case, that will be, let's say, r prime, which is going to be 60g. This is going to be 60g m into g, and that is going to be also equal to the normal reaction force on the man in this case. Okay, then in this case the different forces acting on the system are: on the string the tension force is T prime as a new force, the normal reaction force on the man is R prime, which is 60g, that I have noted already, 60g. On the box the tension force in the opposite direction is again same as T prime. on the box the normal direction force will be acting downward, which will be R prime. The weight of the man will be acting downward, which will be in this case of course the mass of the man as m1, so it is m1g, and the weight of the box will be acting downward, that will be m2g. So these are the forces that is acting on the whole system. So under these forces the man is going to move upward with an acceleration a, also the box is going to move upward with an acceleration of a. Now if I draw the free body diagram of man, so FBD of man will now give, so let's say this is the man, the man is expressing a T prime amount of force upward, with that R prime force upward, and the weight of the man is acting downward, which is m1g, and due to which the man is moving upward with an acceleration of a. So then I can write that for the by applying the Newton's second law in the upward direction, we can write that the net force, which is T prime plus R prime minus m1g, is equal to m1 times a. m1 is the mass of the man. So from this I can write T prime is plus R prime is the actual weight of the man, basically that is 60g, minus m1 is 60g is 60, m1 is again 60, that will be 60 into a. So this will give T prime is equals 60a. So let's say this is my equation number 1a. By drawing the FBD of the box, I can write the free body diagram of the box will give us that the net force on the box in the upward direction is T prime, in the downward direction it is R prime plus m2g, and out of which the box is moving upward with an acceleration of a. So by applying again Newton's second law in the upward direction, we will write that T prime minus R prime minus m2g is equal to m2 times a. Now T prime minus R prime is, as we know, R prime is 60g minus m2 is 30, so it will be 30g, is equal to 30 times a. So from here I will get T prime equals 30a plus 30 plus 60, that is 90g. Okay, so then by multiplying 2 with this equation, we can write 2t prime is equal to 60a plus 90 into 2, that is 180g. So let's say this is my equation 2a. Okay, so then I can just write that from equation 1a and 2a, I can write that 60a equals to T prime, right? So I will write from 1a and 2a, we can write that 2t prime is equals 60a, which is 60a, that is T prime, right? That will be T prime plus 180g. So this implies that the new force applied on the string is nothing but 180g. If we put g equal to 10, then we will get T prime equal 1800 Newton. So this is the answer for the second part of this question. So the force that need to be applied on the second case is 1800 Newton.